Hello everyone. So in this video, in the chapter called Working with NumPy, we're talking about extracting condition-based subsets. Now, what do you mean by this? You have learned how to split an array in the previous video. You have learned how to slice arrays in the previous videos, okay? Here, we're not talking about slicing an array based on the indexes, but getting data from an array based on a certain condition or certain conditions. Okay, so you have elements in your array and you're picking up only those elements from the array that satisfy the condition that you have specified. That is what I mean by extracting condition-based subsets. Clear? Okay, so how do we go about with it? How do we do that? Let's look at the first method. Okay, now for that, I have created a 2D array. If you see just above the word example, I've created a 2D array. Let me just diagrammatically draw it. Okay, but we actually don't need the diagrammatic representation here because we're not talking about either splitting or slicing where we need to know the indexes. Okay, but still, just to let you know that I have created a 2D array. I am drawing the 2D array. Okay, and we know that each row of a 2D array is represented within square brackets. So I'm creating that for you. Okay, fine. Now the question tells me that I am supposed to print all the values in the array that are more than 5. Okay, so there is a condition here. I'm not talking about elements from index 1 to index 2 or something like that. I am talking about elements from the entire array that satisfy a certain condition. And what is the condition? That the value of the element has to be more than 5. Normally, how do I print an array? When I say print in bracket A, what happens? The entire array gets printed. When I say print in bracket A square bracket 1 comma, let's say 2, if I write this, what happens? A particular element that satisfies that index locations that you have given, that means row number 1 and column number 2. This is your row number 0, row number 1. So it's talking about this row. And in this row, it's talking about something on column 2. This is column 0, column 1, column 2. So in short, it would have displayed the element 3. Now this displaying, we are using the indexing method. The first display is talking about displaying the entire array. Now coming to the question, I'm not interested in the entire array. I'm not interested in an element which is at a particular location. I am interested in the element that satisfies the condition. And the condition is that the value of that element has to be greater than 5. So how do I do that? Please look at this print statement. When I say print A, and in the square bracket, instead of specifying the index location, I mean the axis 0 numbering or the axis 1 numbering, I have specified a condition which says A greater than 5. In this scenario, the output is going to be all the elements that are greater than 5. Now, if you look at this array carefully, let me look at the one that we have written here. What are the elements that satisfy the condition? I have 7, I have 6, I have 9, 10, 9, 11, and 18. So what does this statement do? It gives me an array, a one-dimensional array, which satisfies this condition. So the output is going to be nothing but like this, like what you see on the screen. So you get an output where it says 7, 6, 9, 10, 9, 11, 18. Now remember that your output is returned to you as a one-dimensional array. Okay. And the elements are all the elements that satisfy that condition. Okay. Another way of doing the same thing would be, I am just making it longer, but the same thing would be, I could say X is equal to A greater than 5. Okay, so the condition, I am storing it in a variable called X. And then I could say print a square bracket. Now, instead of writing a greater than 5, a greater than 5 is already represented by x. So you write a in square bracket x. It would do the same thing like what we have written in the example. Another way is I write x is equal to a square bracket a greater than 5. Now, what does this mean? This basically means pick up elements of array A, which are greater than 5, and store it in X. So X is a one-dimensional array, which has all the elements of array A, which are greater than 5. And when you say print X, it displays the same elements. So whether you wrote like this, or whether you wrote like this, or whether you wrote like this, the answer you would get is this. Is that clear? So this is condition based. Now, if you look at this example, there is only one single condition. What if you have more than one condition? Okay, I'll take you to that as well. Let's move on. Now look at this question. It says, it's the same array. It says the elements have to be more than 2, but at the same time, it has to be less than 10. That means I need to specify two conditions. One is that the element has to be more than 2, but at the same time, it has to be less than 10. Okay, so I have two conditions to be joined together. We have learned when we started with Python that conditions, multiple conditions can be joined together using the AND operator or the OR operator, right? We used to write AND and OR. And I hope you remember what AND and OR does. AND means you should be satisfying both the conditions, OR means you need to satisfy any one. Okay, but when we are talking about extracting data from an array, we do not use the Python's AND and OR operator as such. We use the symbols ampersand sign or the pipe sign, which actually means AND and OR. But in the array, the AND and the OR is represented by, that means in NumPy, the and the or is represented by an ampersand sign or a pipe sign. So just look at the condition I have written here. I wrote a greater than 2. That's the first condition. And because when you say more than 2 but less than 10, it means you need to satisfy both the conditions. So and a less than 10. One important thing that you need to remember here is do not forget to put the brackets for each of the conditions within the square bracket. This is the square bracket of the array that you have written, array A. And within the square bracket, previously we just wrote a single condition. But if you have multiple conditions, remember to put them in round brackets. Is that clear? Now, again, this, you could have written x is equal to and written the condition. That is a greater than 2 and a less than 10. And then written print a of square bracket x. Is that clear? So this example is talking about using and. Let me take you to the next example, which will tell you how to use a OR operator. So if you see here, before I go to the next slide, I've only got elements that satisfy this condition. Check clearly. You have only got elements which are either greater than 2, not either, greater than 2 and at the same time less than 10. Okay. Now coming to the next question. The next question has again two conditions. But here the condition is not using and. Your elements have to be either less than 2 or they have to be more than 10. So can you see the or operator that I've used here? That's called the pipe sign. Okay, a vertical line. And I've written the condition. And when I execute this program, what am I going to be getting? I'm going to be getting the output as shown here. So if you look at all the elements of the array, the only elements that satisfy these conditions, that means value need to be either below 2 or the value has to be above 10, are 1, 11 and 18. Now what you need to remember is in this extraction method, the answer is always going to be a one-dimensional array. The answer is always going to be a one-dimensional array. Okay, let me just take you to the next slide. Let me clear my annotations. Okay. Now this was the first method. You write the array name and within the square bracket, you write the condition. There is another method of extracting elements but that specifically uses a function called extract of the NumPy array. So I'm using a function named as extract here. So you write the name of your module, which is NumPy, or you could also write NP if you have, given an alias name. You write the condition that needs to be satisfied and the array that you're referring to. So again, I've taken the same array. Now look at this. This is exactly similar to my first example. I wrote np.extract a greater than 5. So np is an alias name for NumPy. You remember, I've not written here, but remember, always remember when you're working with the arrays, this line is very, very important. Otherwise, your array things do not work. So import NumPy as NP is important. Then you write np.extract. So I'm specifically using a function named extract. The condition is a should be greater than 5. And the array that I'm referring to is array A. So finally, what is happening in this scenario? I'm extracting the data from array A that satisfies this condition, and I'm storing it into a variable named B. But extraction also gives me a one-dimensional array. So if I execute this program, the output that I'm going to see is the same that I saw in my first example. Okay, so there are two ways of extracting data. Either you write A and within the square bracket you specify the condition. If A is the name of your array, okay, not necessarily A all the time. Or you make use of the extract function. Now in the extract function also, like I said, you could be making use of the AND operator or the OR operator. Clear? So do not get confused between splitting, slicing, and extraction. What does splitting mean? You have a particular array and you're dividing the array into 3 equal parts, 2 equal parts using the vsplit, hsplit, or split function, or unequal parts using the split function with indexes. What does slicing mean? Extracting a part of the array based on the index values. That is your row index, that is axis 0 index or axis 1 index. But extraction, when you talk about extraction, I'm specifically talking about extractions based on a certain condition. Clear? So I hope it is clear. The same thing is applicable even for one-dimensional arrays. Whatever we say for two-dimensional arrays works even for a one-dimensional array. When you work on a one-dimensional array, your answer is also going to be, what will you get? I mean, the extracted elements are going to be a part of a one-dimensional array. When you work on a two-dimensional array, the extracted elements are going to be a part of a one-dimensional array again. So the answer is always a one-dimensional array, whether you're working on a one-dimensional array or a two-dimensional array. Is that clear? So I hope everything is understood till here. And we're almost at the end of the chapter. There is one small topic left. Okay. Okay. Bye.